Okay, I will check that both the 31st and 1st. Okay. Okay. So about the Apache Hive, it is another application which is developed by the Facebook to do for their convenience, because Hive is written in SQL language. Those people know only SQL language. They are not comfortable with the Java, so they wanted to do the analysis based on their own known language. Okay, Facebook, it is a completely of a data, right? Like so many datas are loaded into the Facebook. And nowadays it is a trillions and so many bytes, more than zettabytes and all. Per day itself, it is like in petabytes, and data are loaded. So they wanted to find some the good solutions or business solutions, like if an user is logged in, what kind of a videos he is going to view it, those are listed nowadays, right? Then based on the history, we'll do an analysis, and it will list the user interested videos or user interested contents, or if you also view some about the courses and all those information, all these things will be done using the Apache Hive. They are using Apache Hive for doing it. Not only they, many uses it. Okay, and what are the advantages and disadvantages of that, we will see it now. Okay, so it is another application which runs on top of the Hadoop framework. Okay, it doesn't run independently. You need an Hadoop distributed architecture, MapReduce engine also. On top of that, this Hive will work. Same like Pig. Okay, it will start the MapReduce mode. So what is Hive? Hive is like a data warehouse uses the data warehouse infrastructure tool to process the structured data in Hadoop. It works well with structured data. It is a distributed and tolerant fault tolerant. It distributed, when I say it is, you can have a Hive installed over a Hadoop architecture. In that way, it is a distributed. Hadoop architecture means Hadoop itself will be running in a different nodes, right? Data can be present in a different nodes, data nodes. Okay, and which is in Hadoop architecture. So you can have an hive which can do its processing on these data which are present in a different data nodes. That's this how it is distributed. There can be n number of nodes. Normally some 4,000 nodes, minimum of 4,000 nodes shall be configured using the Hadoop data structure. Minimum to maximum, I think 4,000 nodes. After that, scalability issues and all will come. So they say like 4,000 nodes can be configured, and the data can be stored across those nodes.
Ma'am,
So
audio little bit low.
my audio is a little bit low.
Yes, ma'am, it's not clear.
Audio not clear. Okay, I will check it again. Maybe I will
Ma'am,
increase. Yes.
no, for us it was okay, I think.
Okay,
For me, it's
fine. No?
uh, yes.
Okay, then I will increase the volume. I will only increase and
Now clear,
speak.
ma'am.
Now
Now clear.
fine. No? Ah, okay.
Yes.
Okay. So since it is going to work on an underlying architecture of Hadoop, so it supports a distributed. Say if a Hadoop framework you have it, and it has some n number of 10 nodes or 100 nodes already configured. If you want to use the application Hive for doing some processing, directly you can install the Hive application. It is not like the nodes has to be configured to support the Hive installation and all. Okay, and it is a fault tolerant. Fault tolerant we know because Hadoop has the highest facility of giving the fault tolerance, like the replication factors are all come into picture. So that is why Hive is also, since it is depending on the Hadoop framework, Hive is also highly tolerant, fault tolerant. One fault tolerant means any data is lost or missed in any of the nodes shall be taken taken from the other nodes because it contains the replica. Hive uses a language. The language, see, in Pig we used a grunt shell to write Pig scripts, right? So Pig script is the language. Okay, like it is, this Pig is developed by Yahoo, and Hive uses a Hive query language. Okay, Hive query language in order to write our queries. So same like SQL query languages, only it looks similar, but some of them are specific to Hive also. There are commands present, okay, which provides SQL functionalities. Okay, it is easy Hive because you know SQL. You can also write Hive commands. It abstracts the complexity of Hadoop and provides a simple declarative language. Complexities of Hadoop, so you don't have to worry how you have to write a map program or you have to write a reduce method functionality. Those things were taken care by the Hive itself. Only you write commands like select. You can directly give commands like select a star from uh, some table or all. You can create a table. Okay, table. Likewise, you can give, it will retrieve your data and it will give. Okay, but whereas in our pig we used to give load the data into a relation and dump it and check. No, likewise in Hive also you can directly select the data which are present into your table and see it. uh, what is the table, how it is coming as a table and all, I will tell you. Okay, how it is loaded as a table and all, that I will tell you. And simple declarative language means declarative statements means each statement which are we giving in the MySQL, right? Those are declarative statements. It's like one complete statement, like a select query or alter query, update query. All the this are called the declarative statement. That's why they say provides a simple declarative language. Okay, so how the architecture of Hive works is the data which are present, data normally where it will be present, it will be present in your HDFS. This data we can load into the Hive tables. We will load it into the Hive in the form of tables. We will load it. Okay, in the form of a tables, and it means the data which is loaded into the Hive will be stored in the form of rows and columns. Okay, that is why Hive is good in working with the structured data. Okay, that's what, right. But efficiency is more. You can ask me why don't you use MySQL, then why are going for a Hive? But MySQL won't work in a distributed architecture, right? It is a standalone. In order to give it as a distributor, you have to have a separate servers connected together, and the data you have to bring it together to where the processing, sorry, yeah, the where the processing is happening. That all things we saw in the class initial classes. But in Hive it is a distributed architecture, so in that case you can go for this Hive. So what I'm trying to say is, when you load the data into the Hive framework, same like how we load our data into a relation in a pig, here you will load it as a tables. Okay, and from the tables you will start writing the queries like select star from on all those queries, which are all SQL queries, and that will retrieve your data, and you can also do processing with that data with the queries itself. Okay, it will also support joins and all. We'll see that. Furthermore, Hive history, it is developed by Facebook. Okay, Hive is also one of the technologies that's being used to address the requirements at the Facebook. Mainly, they have developed it for their functionality to address their queries, and it can store upwards to, now this data might be is a little old. It can be doubled. Okay, if, 4 petabytes or zettabytes it would have gone. We have seen, no, and like 10 power 7 amounts of data. Okay, that much amount of data it might be storing, and loads more than 20 terabytes on a daily basis. This would have increased also now because everyone has a Facebook. More than that, other social medias also has come into picture, news like instas and other things, Twitter and all those stuffs. So the data loaded would have increased a lot. Okay, so other companies also use this Hive. Okay, now used by the number of companies like IBM, Amazon, you know, like they have a huge all over the world, all information they have it in the form of commercial side, and Yahoo, Netflix, and many others. Okay, that is how who has developed this Facebook for that purpose, but it is widely used by others also. Okay, and the features of Hive, what Hive does is it is like a same like how when SQL, any SQL databases does, it is extract, transform, and load your data. It means the data extract is where it is going to get extracted. The data is stored in HDFS. In the HDFS stores the data in a file format, right? Because HDFS is a file system, it stores its data in the file format. Right. So those data will be extracted and it is just transformed and stored into Hive in the form of a tables. Okay, and it is loaded for processing. So that is what they call it as an ETL process. Okay, tools to enable easy access of data via SQL, thus enabling data warehousing tasks such as extract, transform, and load. Okay, and reporting of the data and the data analysis, all those things also you can do with the results which you get it from the Hive. It is a scalable, familiar, and it is extensible. Extensible, as I told, like any number of data nodes you can have it. You can install a higher infrastructure or a Hive architecture, then it will work on that. Okay, scalable also, the number of nodes can be increased. Same like Hadoop, because underlyingly Hadoop supports more nodes, more distribution. So Hive also will work a mechanism to impose structure on a variety of data formats. Okay, so if it is of other type of data, so not only like a CSV files, other type of structured data like a text files or semi structured like XML files. Okay, all those files also you can work on with the Hive. Okay, access to files stored either directly in the Apache HDFS or other data storage such as HBase. So what they are saying is, I was keep on talking about the underlying architecture with Hadoop and HDFS where our data is stored. What they say, there is another database, okay, database which is HBase. Okay, and this is a NoSQL database, no SQL database. It means it doesn't have any structure at all. It will store database. It will store the data in the form of column oriented. They call HBase as a column oriented database. We will see it in the next after HB Hive. We will see that one, column oriented databases. Okay, uh, so it Hive can also, it is not necessarily that it works with the data which is present in HDFS. It can also connect to other databases like HBase or Cassandra. Okay, that also we will see. MySQL. Okay, other databases are like a PostgreSQL. It can take the data from here or local machine, it's a local Linux machine itself, and then can work on this. But normally we won't go to the local, no, in commercial environment, it means in industry, but you will work on data with other databases. So Hive also takes the data from other databases and works. That's what they are saying in this line. Okay, and query execution via Apache test, Apache Spark or MapReduce. Query execution means the execution, that analysis part, that can be either done by Apache Spark or MapReduce. As I told before, MapReduce, if you don't want to use an engine, you can go for the Spark engine. Okay, that is highly efficient and faster when compared to MapReduce, or test engine is also developed. Okay, either of that engine you can use it. Okay, and querying in Hive is very simple, as it is similar to SQL. It is easy also because same SQL queries you will write it. And procedural language with the HPL and SQL. Those, see, MySQL language which we use, that we call it as a SQL language, right? For a Hive we are saying it as HPL SQL language. Hive procedural language SQL likewise. Okay, and the subqueries can be query retrieval. You can also use other tools to retrieve the queries. See, subquery, we say like we create queries, right? Like you can create a table by copying a table. Okay, create table, some table name you give tn, and you can create another table as create sorry, select from, here it is a select from table 2. Okay, so likewise you can create, you can use other tools to run on subqueries also. Okay, this we are not much seeing because we will work on only with the Hive. This is there, you can know it as an information. Okay, and normally sometimes they'll say that Hive as a database. Hive is not a database, it is a query engine only. Okay, that will query your data and we can do write the commands to do analysis also. Okay, and the limitations in Hive. Till now, any doubts? Till now, is it okay?
No.
No, right? Okay, I will continue. This is only introduction class. And the Hive limitation. Apache does not offer a real-time queries. Apache Hive, this is okay, and a row level updates. Actually, for online transactions and all, this is not good. See, there are two things. Okay, one is like OLAP, online analysis processing, and another is OLTP. Okay, online transaction processing. Transaction means this kind of architecture, or this is a norms to be followed while we are doing transaction processing. Transaction processing, you understand, no? Like if you're doing banking application, you're using banking applications and all. Okay, banking applications, there they do the transaction processing. Okay, this norms that they will follow it, rules or the set of rules. The transaction should be very quick. It should they should they it will not tolerate any latency in the sense any delay. Okay, between the transactions. Say if I put money from an ATM, deposit some money, then it has to immediately get updated in my account. I uh, log into my ATM machine, okay, with my PIN code, and then I do a deposit of some amount. Then I go and check the balance. It should be immediately updated. There, it will not tolerate any latency, right? If there is any latency, someone can tamper that the transaction details, okay, from the user to the bank, and he can redirect that amount to his account. So all these things should not happen. So if it is like fast transactions and all, then Hive is not good because Hive is a little slow. Okay, for that processing, you will use another applications. Okay, if it is a part of analytic processes, analysis means like if you wanted to check like how many users have viewed a particular movie like Kung Fu Panda in Netflix. Okay, then you put that in the top of the list. Or if some series are there, Ozark series or something, that you put it in the top of the list. So for this, there can be, you can tolerate the delay, right? And if the stock markets and all, that keeps changing faster, no? So that there you cannot tolerate any latency means delay between the transactions. Okay, delay between the start and the end of a transaction. Okay, that for that reasons or all, you will not go to Hive. Okay, latency for Apache Hive queries is generally very high, the time delay is high. So when it is sensitive information or mostly banking transactions and all, they will not use this Hive queries, or this Hive application they will not use there. Okay, and furthermore, so this is the architecture about the Hive. Hive architecture. So in pig we are using the grunt shell, right? That CLI is the command line interface. In your Linux, when you open the terminal, you're typing commands to CLS, grep commands to view the list, or touch command to create a file, and all those things, right? Those are command line arguments, we say, or the command line interface. Through commands we will communicate it. Likewise, uh, that grunt shell is a command line interface which you can communicate through the pig environment. Likewise, Hive is also having a command line interface. Okay, otherwise there is also web usage. Web UI means like our if any portal is there, like, right? So we have a registration portal. You people have entered all your details. That is an user interface, right? And but underlyingly, there is a code has written, no, that you have to capture your data and I have to put it in the database and check it. All those things. So that front end is the user interface. That way also you can submit the queries. Okay, write queries to the, you can communicate with the architecture, with the architecture of the Hive infrastructure. Okay, either command line, that is the Hive uh, QL. Okay, query B line or command line interface is also present. Okay, for the Hive, and or else there can be other applications like HD site, Insight. Okay, through which also you can write your queries. Okay, how the architecture is like that is stored is, say I told like the data stored in their HDFS will be loaded into Hive. Okay, in the form of a tables, loaded into Hive in the form of tables. Tables mean what you can think of. Whenever we create a table, what we used to give? How do we create a table? What information we provide about the table? Well, we create a table, what we give the information, rows and columns. Okay, we'll tell now how the columns should be. What is that? Schema, yes. The schema information we have to provide it when we are creating the table also. Okay, so that schema information about a table will be present in a place called the data meta store. Okay, in Hive there is uh, meta store, metadata, you understand, right? Metadata means data about the data. When I say SQL table, a data about data, it means the schema. We are doing a describe of any table, right? Describe of any table name. The table name gives information about the data. About the data means information about the rows and the columns, about the actual data which I am storing. So that is called the metadata. So how Hive will store the schema information is like it will store the schema information of the table which we are creating, where you wanted to store your uh, data set. Okay, that will be present in your meta store. So this meta store is actually nothing but a database. Okay, database. The database can be a MySQL database. Inbuiltly, there is a Derby database which will come along with Hive, and it can be like a PostgreSQL database. Okay, or it can be an Oracle database. Okay, so this data in the information about the table which I am creating, the table which I am creating means into the table only I will load my data set. Okay, and I will start querying from the tables only. Same like in our pick into a relation, we stored our data set, right? Load, using the load command, we stored our data set, and we start writing grouping by or filter or sorting, everything we did it on the relation, right? Because this relation will have the reference to the actual data which is present in the HDFS. Similarly, in Hive, we will create tables. Okay, we will provide the schema information for the tables and load your data into the table. The information about the table, that is the schema, will be stored in your meta store. How the actual functionality will, yes, index is index, you should not say, Amalan. It is information about structure of the data, you can say. Index means indexing is indexing, if you say like particularly identifying some columns or something like that. Structure of the data, you can say. Okay, how the data looks like, what is the data type for the column. Okay, if I give a data type for any column, then that data only they, if the data type of a column is a string, then that data only I can store it likewise. Okay, so how the architecture will behave is like the information about the table will be stored in the meta store. This they normally say it as a metadata. Okay, uh, metadata which is actually stored in a database. Okay, data is not stored in your database. Okay, metadata only should be stored in a database. That is, a schema information only will be stored in your database. Any query you are passing here to retrieve any data, say for example I do retrieve or update or alter or do anything for from on the table which we have created, it will go to the Hive process engine. Okay, and from there it will for the table. If select star from, say I give table as a student, the schema about the student will be present. That is the student ID is integer. Student name is mm, where care something like that. All this information will be present in the meta store. Okay, so what this Hive query language process engine will do is it will go for the student schema. It will try to find the schema in the meta store. Okay, and after that it will retrieve the data from the HBase, because that HBase or HDFS it is present here only, no, on the HDFS, and with that data it will start the processing engine, which is a map reduce. Is this clear? Metastore contains the information about the any table which you are creating in the Hive. Okay, metastore is usually will not be of it small size. Why? Because we are not storing the complete data in metastore, but we only store about the schema information. This is how it works. Okay, if you don't have a metastore, or if you delete the metastore, it is which is present in your machine, then it will not understand the schema about the table which you are querying. Then it will not be able to, it will say that it is not present. Okay, it will not work properly at all. Okay, is this architecture is fine? I'll clear this. Okay, so you pass a query, it goes to the query engine. Okay, anywhere using a web GUI or do a Hive command line or HD Insight, it goes to the engine. Engine will take the schema information. Okay, schema, it will request for the schema information and get it for the table, and then it will go actual data. See, the table which we create is a reference. Okay, it will also give us the result in the form of tables only, and the actual data is present in HDFS, that it will refer and start the map reduce job and give us as the analysis. Okay, is this okay? Okay, I will move on. So each of this information about the architecture is given here. Okay, explanation about that and the working of the Hive. Okay, we will see that. Mm. Okay, so about the user interface can be anything like a web GUI or a command line or the Hive HD Insight. Okay, it is this is if your story if you have installed a Hadoop infrastructure in your Windows server, and if you wanted to communicate to a Windows using the in the Windows environment, okay, then it is HD sites developed by Windows guys. Okay, Microsoft guys. Okay, and Metastore, Hive chooses the respective database servers to store the schema or the metadata of the tables. That you should remember. Okay, if somebody asks what is architecture or what is a metas data store, they may confuse you asking like it stores the complete data, or it stores only the schema like that. It only stores about the schema. That is the structure of the tables which we are creating. Okay, columns in a table, their data types and HDFS mapping, because you need to know no, where the actual data in HDFS is present, that it will also have that. See, in grunt shell in pig also, when I say I load a data into a relation, it means actual data will not be present in this relation. It will refer, okay, it will refer to the actual data which is present in HDFS only. Okay, that you should know it. It is because it cannot hold the data only. It doesn't have a separate storage space. Pig, it uses a storage space of HDFS, but it loads in a relation will have a reference to this HDFS. That's why it starts a map reduce and it will work on it. Similarly, in the same case in Hive 2. Okay, just remember that. Then the processing engine, it is like an engine of a SQL standard query language, and it is similar to SQL for querying on schema information on the metastore. Okay, it retrieves the schema information It is one of the replacements of traditional approach for MapReduce program. Instead of writing MapReduce program in Java, we can write query for the MapReduce job. Okay, process and process it. There we have a MapReduce engine. Here we can use the Hive process engine. Okay, but underlyingly it will go and call the MapReduce. It will start. Okay, we have seen no in MapReduce what all it has done, splitting of the data and all shuffle and sort. All these things will be done by the engine, MapReduce engine itself. Okay, but you can write a query and give it to the process engine that will take care of that. MapReduce phase is hidden, guys. That's what in the other application which are developed by the other companies, they reduce the difficulty of MapReduce that is hidden. So they have written their own languages. That's all. And the execution engine, the conjunction part of the Hive QL. QL is query language. Okay, process engine and MapReduce is the that is the merging part where they both meet is the execution engine here. Okay, this MapReduce and the execution engine. Okay, that's what they're saying. Execution engine processes the query and generates the results as same as the MapReduce results. Okay, whatever the MapReduce results it's giving, it gives the same. It uses the flavor of MapReduce. That's what I told. So HDFS, it can use HDFS or HBase also. Okay, to store the data. That this I have already told. Then components in detail. Each of the components they are talking in detail. Okay, clients, when I say which is nothing but uh, the outside client means I am as a user, because I am going to find how many Netflix movies are rated in the top. Okay, then I will give it the select star from Netflix movie, in Netflix movie table, and whose ratings, where ratings, okay, ratings are greater than 4. Okay, likewise, so I am the client. Okay, the client can be connected to the Hive, okay, framework, or a Hive application, either as a thrift client. This is old, this is little older application. Okay, or a JDBC client, or as a ODBC client. See, JDBC, ODBC are those clients which communicates with the database. We also have pending with that one, no, that I will show. Okay, database. Database means Java application which are communicating with the database uses this JDBC drivers. Drivers in the sense, because this is completely different. Uh, what you can say, like Microsoft and Linux, right? Completely different environment itself. Java is a programming language, data is a storage unit. So if you wanted to connect between these two, you need a driver, no? That kind of facility will be given by the JDB, Java database connectivity. Okay, since this is data, the Hive metadata is stored in a database. I told, no, like MySQL or Cassandra or any Oracle, and or Derby databases. Then connectivity from our client, it means myself, or through a web GUI. Okay, or through a Hive command line, or through a Microsoft application, may happen by the JDBC, or you can also use ODBC connectivity. Okay, ODBC is the for the Oracle connect driver. Okay, otherwise it will happen through JDBC connectivity. These are in detail. If you wanted to know about how it is all working or connectivity also, I'll post some books, you can read through that. Okay, so you can just understand this one. Okay, then beeline is the command shell, command line interface, like a grunt shell. This is also a shell. Okay, you can launch this shell and write your SQL commands, which is the Hive commands. Okay, Hive commands, we say here it as Hive commands, we will not say it as SQL commands. It is all written in Java. Okay, Java based console. Okay, Java, that's why you need a JDBC connectivity. Okay, this you can merely remember that it is a shell, not command line. Okay, command line shell where you can write your queries. And Hive server too. See, there were that server Hive, any, if see, if when you talk about any architecture, you have a server and your client, right? Client is the one which communicates with the server, and server takes it to all your processing engines and all. So Hive server 1 was the older version. Okay, this is the newer version. Now it is the newer version with some features which are effective in this. Okay, it enables client to execute queries against the Hive. It allows multiple clients to submit queries to Hive. So many clients can connect. Okay, many clients can connect us. I can also open a Hive shell and write queries. And you in the same machine you can open a Hive shell and write queries likewise. Many users to connected. It is basically designed to provide the best support for Open API clients like JDBC and ODBC. That's what. If you are trying to connect through the connective connector, normally it connects with this, then it gives a good support. That's what they're saying. You can read through this. And the Hive driver, it is the receives the HQL statements submitted by the user through the command shell. It creates the session, okay, handles for the query and sends the query to the compiler to the next layer. Okay, here it is there. Okay, this is how it works. Okay, the application connects, I mean application contacts the JDBC application or ODBC application or UI. The UI will contact here. Okay, that it goes to the client. Okay, they will have some logic here. This is a completely client, and it goes to the server. This is the server part where the server will send it to the driver. Okay, the driver will take the data from the meta store. What driver will do is the query which we are sending, no, the compilation has to do, right? Compilation in the sense like semantic checks of basic semantic checks. Semantic means that character and all properly we have given, that word we have select word we have given properly, those checks, and then returns back to the driver. Driver takes the schema data from the meta store. Okay, and then it gets goes to the optimizer will be, this is an optional case. Okay, otherwise it can go directly to the map reduce. Okay, there this all which we have already discussed, taken care by the map reduce engine, MR engine. Okay, we can say like that itself. Map reduce and resource management yarn. Okay, will come into picture. So till this portion, it is the Hive architecture. That is what they have described here. Okay, compiler passes the query as I told. The syntax checks, semantic checks it will do, and on the different query blocks and query expressions by using the data stored in the meta store, and generates an execution plan. This is what we are seeing. No, even pig creates an execution plan. Okay, first from the relation where it all has to go. All these things. Likewise, here also it will create a directed directed acyclic graph. This is a data structure. Okay, say data structure, you know, right? Data structure mean we used to have a tree data structures and map data structure and all. Graph is a special kind of a data structure where your data shall be stored with the row matrices and edges. Okay, so the execution of how it happens, say for example I'm doing a selection of the data, then I am going to do a filtering of the data, then I do a mm, what we can grouping of the data. All these things will be drawn in the form of a graph. Okay, that is what the compiler will do. Then after that it goes to the map reduce job. Okay, so the optimizer performs the transformation operation on the execution plan and splits the task to more efficiently. So it optimizes. So if you remember in our map reduce engine, which what is optimizer? If you wanted to do an optimizer, we can use a method, right? We can use a class, not method, class. What is that class? Do you remember? In map reduce, Repeat the question in map reduce. You are following. Everyone is following the class. No, am I not going fast? Right? Please let me know. No, ma'am means not fast. Okay, that's what you're saying. Okay. What I my question is, when we are doing, we used when we are writing a map reducer in a Java program, we give there was a one class which we can use it for optimization. You remember if I told like the temperatures which you see, okay, rather than uh, you can find the maximum of a temperature. Okay, if it is coming from two outputs. Okay, two outputs if it is giving from a two mapper method, then you can find the max in the say if it is 10, 5, 4, and 11, 12, 13. So here itself you can it will give a result like rather than combining together in a reducer. Okay, map of max of 10, 5, 4, 11, 12, and 13. No, it's not reducer. Okay, this is what reducer will do. Okay, max of 10, 5, 4, 11, 12, 13. The mapper here if you find the max here, 13 is the max, it gives the result. Rather than going to the step, if you can do this uh, find the maximum in the splitted output itself, like this is the maximum and here it is only 13, right? From both the set, both the list. Okay, so later on reducer what it will do, yeah, max 10 comma 13 it will try. Okay, see if checking the maximum in five numbers and checking the maximum in two numbers reduces the time, right? It is an optimization thing. So which class it was doing, that class is combiner class. Go revisit it. Okay, combiner class. If you have set a combiner class, the output which it is coming from the mapper program. Okay, like this will be your mapper output, right? Your combiner, how many outputs it is coming, each map task will give one output, right? There itself it will say, for example, if it is an aggregate function, it will find a maximum or minimum like that. Okay, forgot. Guys, you forget combiner class, you remember? Okay, just go and check it. Okay, ppt you see it, then you will understand. Yes, that is there, I know. Hadoop revision is there and they wanted to work on some data sets also, it is there. We'll do that. Okay, then what else? Okay, likewise here also optimizer is there. That's why I picked up that. Okay, and about the execution engine, it will do a optimization after that. It will try to merge your result to the map reduce. Okay, and it will take care of all the dependencies using Hadoop. Okay, and the metastore, as I told, like it is a central repository, but only stores the schema information, not the complete data. Okay, metadata information about the structure of the tables. There is some concepts like partitions and all. Partition means huge amount of data set will be there. No, say for example, I have an employee information of a company, say for we take it as a TCS or Wipro. Okay, then you can segregate or partition this employee data set. Okay, based on maybe city, say Chennai city, CTS people. Okay, or Wipro or from Delhi, it's there, I'm not sure, or from Bangalore. Okay, all these things, so you can partition it, partition, and uh, partition is like a filter only. Okay, you can partition the data based on any particular field value and then filter it or start writing queries only to the partition. Say you remember in MySQL we have views, right? We create a views because we don't want to write the same command again and again, right? Big queries. Then from the view it will give the result. You can directly write select star from views. Okay, likewise, so views is not created separately, right? It will always refers to the original data, but it will contain the references to which are the fields we are referring it in while creating the view. Likewise, partitions also work. Don't worry, we will see it later on. Okay. It also stores information of a serializer and deserializer required for see serialization concept and deserialization concept we have seen in our Java, right? Yeah, actually, that is, all the data is here, all data means the data set complete information in Hadoop will be stored in serialized format only. Why? Because a transferring of data is happening, right, between data nodes. Right. You don't have to transfer the original data in that case. It will these are all taken care by the framework. It will store save convert all the data into byte codes. Okay, all the objects. The data means here everything is object only, right? Because it is written in Java objects, and it will transfer in serialized format only. That is a byte codes only. Okay, objects are converted into serialized and then transferred to from one node to another. When we are saying transferring, it means the network is should be present, right? The connectivity should be present, right? That's what it was, all serialized data. Okay, for read and write operation and all those things. Okay, in okay, if you are going for a, other than a non-Java application which is trying to communicate with your Hive, okay, it means if you are trying to write queries other than the JDBC or ODBC client, then we can use the thrift service. So this is also one of the application which is a little older one. I'm not sure now they are not, they may not be using it. Even Cassandra uses a thrift, but now it uses another query language SQL, but that we will see it later. Okay, and in the embedded mode, the client can directly interact with the metastore using the JDBC connection. Okay, remote mode you can use this. Embedded mode I am not sure. I'll check this. What is this embedded mode in Hive? Remote I can understand. We can understand. No, like communicating from anywhere you can communicate. See, you can log into the virtual lab right remotely, and you are working on that. That is a remote connectivity. But the server is present in Nilek Chennai. You are connecting. You have given a portion of a server, and that Linux everything is Linux is installed. Ubuntu is installed for you and given it to you. That space you can connect it from anywhere and work. That is remote connection. Okay, even that in Windows also we will download our virtual box. Okay, that is desktop only. This Windows you can connect it remotely, right from your home. Also, you can connect your laptop or office machine. Those are remote connection. Okay, and H catalog is the table or the data or the storage management layer for the Hadoop. Okay, this contains the information about where the data is present in the H catalog in the Hadoop, which is used by the Hive. Okay, Hive uses this to locate those datas. Fine. So this is about the execution. Execute query. The user interface calls the execute interface to the driver. Okay, and it will get the plan. Okay, the driver accepts the query, creates a session handle for the query, and passes the query to the compiler for generating whatever I have told here. First it goes to the compiler, okay, any command, then from the compiler it goes back to the driver, and driver again fetches the schema for the table from the data store, and then it goes for the map reduce. Okay, get metadata. The compiler sends the metadata request to the metastore. Okay, send the metadata. The metastore sends the metadata to the compiler. Okay, the compiler then sends the generated execution plan. Well, after that only it generates the execution plan, and that it goes to the driver. DAG graph it generates. And after receiving, okay, here it is not like compiler going to driver, it is like compiler going to metastore. Okay, this is wrong. Compiler is going to the metastore, gets the information, and then create a DAG graph, and that then goes to the driver. Okay, after receiving the execution plan from compiler, driver sends the execution plan to the execution engine for executing the plan. Okay, same thing. And then map is submitted to the map reviews. Just a moment. Okay, sorry about that. Okay, we will proceed further. Okay, that is all with this Hive. So, any doubts in this? Maybe we will do an installation, or we will do the installation tomorrow also. Anything is fine. Is this okay, theory part? Thank you. Okay, download it from the internet. Hive 2.3.8. Whatever is it, find check the latest version. Okay, I will also check it here because these are all constantly developing, undergoing development things. So if you take the latest one, some may not be fixed or may not be stable. Okay, that's the reason. I'll share this. Apache Hive I'm giving download. Okay, the site will come. Um, Downloads Apache Hive. Okay, in this download or release now, you go to the HTTP, same like how we did it for other pig or Hadoop itself. Okay, here here it is having this one Apache storage. Sorry, Hive 3.1.3 is there, that is released on 17th, last modified 17, or you can take 3.1.2. Okay, in this there is that tar.gz. Okay, 24 megabytes. Don't take bin. Okay, sorry, bin only you have to take, not src. Src is source. Okay, we have seen in eclipse also, right? Whenever we create an project, the source file will come. So like this is a source. Take the bin. Okay, 266 MB. Download it. Click undownload it. This is a tar.gz file, right? Somebody say zoom. Okay, okay, I will show you from beginning. Downloads Apache, Hive Apache. Okay, directly you can give Apache downloads, then download a release now. Go here only. In the HTTP site, you have to download it. Don't go to backup site, HTTP site. In that, we will take one release before, which is 3.1.2 and tar.gz. Okay, not the source, but bin, that is the binary files. Click on that, it will download in your uh, Ubuntu machine. Go from Ubuntu Firefox only, download it. Then all the steps which is given here, you can do that. Okay. Mm, the steps are like this. It's visible, no, to you all? Yeah. The steps, then untar it, like how we created a directory. See, after once we come, before you complete this Hadoop itself, you will only tell me like how to download and configure and all those things. In one of the batches, like that, some issues we faced, students went into the they themselves gave the solution like how to do that, you know. So it will be like that only, you will practice the installation and all easily. Okay. uh, and copy the Hive home environment into your environment. You copy it from H. There is that there will be a template file in your after you download it. If you go to home is the Hive directory. Okay, you have created a directory right here. That is your home directory, and in that directory you will have conf. There will no installation questions and all will not be there, but installation you have to know. You should also know like which are the files you are changing and why you are changing. Okay, because they will ask in interviews also. Okay, in Hadoop, what are the files you will change, what parameters you will change it in order to do the replication, where in which file it is present, they may ask it. Okay, but you should know it. Okay, and h hive env, this you will change it. There will be a file, okay, inside the conf directory. Hive.env.sh template file will be there, that you will change it to hive.env.sh. Then append this to the your hive dot, you will write all these things. This is the Hadoop installation folder, which is nothing but that user local Hadoop. Okay, that you will put it in your hive.env. Now I will show you tomorrow, you just I'm just explaining. Then you have to put your bash rc, update your bash rc. Okay, because when you are launching Hive shell, it has to know where this Hive is present, where are its libraries to run it. Okay, that's for that you will do this. You will source it. Okay, and there are some directories. I told right, meta store. Meta, meta store is a database, and there is a something like tables we created. Okay, so for that tables, in order to create it, you need to create this directories in your hdfs. Okay, that this also you try it using this command make directory. You will create user hive. Inside the hive you will create warehouse. Okay, and you'll also create a temporary directory, and you will give permissions. This is group, right? They are saying, otherwise you give 777 permission to both temp directory and this one. Temp directory will be storing the temporary data. Okay, I'll tell that later on in the next class. And okay, so I told like metastore is a database, right? Schema will be stored in the database. It means to the hive machine we have to configure that data store also, that is the database also. Internally for that we need a driver. Okay, internally hive will come with a derby database. For that we need a library for that derby database library file that you have to download it. You try it till here, then afterwards I will show. I will do it from beginning only because even my machine doesn't have hive, so I will do it from the beginning only. Okay, that also you have to download that path, you have to give, and some properties that hivesite.xml properties also we have to change for our meta store to understand where the meta store is there. And some jbox properties, this is for logging in the driver. I told not to connect through the driver and all that properties you have to change. Okay, then you have to start the schema, that is start the metadata meta store. We'll see that all everything. This will take time. If I start and it will go further, 1 hour it will take. Tomorrow we will do. Okay, tomorrow be present. Faizan, you two please come. Ask your friends to come to the class. Okay. Okay, that is all for now. Any doubts you can ask me. That I will upload it. PPT I have, but I don't know. Recording somehow it is not present in my mission. I'll check that. Otherwise, anyway, as a revision again, I will take that class. Okay, the queries I will put it. That link I will give.